Live. We're live. We are live. Yes.
Okay, today I'm going to discuss this notebook that show you how to use AWS SageMaker for tuning your machine learning model. Okay, first of all, I want to highlight an important detail, I think. Basically, when you create your notebook, you choose a specific hardware, in this case, but this is not the hardware that you will use to train the model. This is just because the training process will run on a different instance.
Question. Let's start from the real beginning. So let's say that somebody wants to train a machine learning model. They have to have an AWS account, right?
Yeah, sure.
Okay, start from there.
Yeah, so once you have your AWS account,
yes,
you basically choose SageMaker here.
Okay.
You choose SageMaker somewhere here. And one of the possibilities that SageMaker offers is to create a notebook. So you want you don't have to manage a whole EC2, a whole instance, but you have only this notebook. Once you create a notebook, typically the notebook is used only for data preparation, and in general, all what concerns what happens before training the model. So typically here, one of the important advantages of SageMaker is that you run your notebook choosing a very cheap hardware like this one that is 5 cents per hour, yes. And then the training will be handled on a separate instance with the hardware that you will choose. Yeah. So in this problem, and one other important characteristic of SageMaker is that you don't need to store locally your training data. So but you can upload them on S3. And then during the training process, the data will be automatically downloaded from the S3.
And this is did you notice any overhead or any delay while loading from S3?
No, because it's who is writing the code doesn't have explicitly to download the data from S3, but data is automatically downloaded from there under the hood by SageMaker.
Okay.
And this again is another advantage for which concern costs, because storing data on S3 is cheaper than storing data on EBS volume.
Okay.
Yeah, okay, so this is the AWS introduction. Let me introduce the problem here. Basically, we have a data set with 500,000 of rows and I don't know, around 1,000 columns or something like that. And of course, we want to train a machine learning model. In particular, here we want to train an XGBoost model.
Okay.
That will learn the classification task. One other thing, when you create a new notebook, you have the possibility to create a specific S3 bucket so that your notebook will so that only your notebook will have the right to access that bucket.
Okay, and where is it specified here?
Actually, here where you see bucket, here you have to write the actual name of the bucket. I didn't put here because it included the name of our client. So
okay.
Yeah. While you create the notebook, if you don't explicitly create a new bucket, AWS does it for you. And at that time, in order to get the name of the bucket, you have to run this command.
Cool.
That returns the name of the.
So it's like a local storage, a local memory, like a drive, so local drive.
The important thing is that only the notebook that you are gonna create will have access to that bucket. Of course, then you can change permission and so on, but by default it works like this. So we can go and look at the code here. Okay, some imports and some boring stuff here, like you get the region, the AWS region you are in. This is just a client for S3.
Yes.
You get the IAM role again.
Yes.
And here, basically, this is the name of the bucket, and this is the subdirectory where I put data. But of course, you can change this. Maybe you can put data directly in this bucket, so you don't need this prefix. Basically, here I'm creating this object, this training input object, that will allow me, or better, will allow the model during training to load data directly from S3.
So there you just need the CSV. Whatever it is in the CSV, it's gonna get loaded into the data frame.
For machine learning problems, yes. I didn't try for images, for example.
Okay.
But I think the process will be similar. Just one important thing, you have to put as the label as first column in the CSV.
Okay, so there is a format there to respect.
Yeah, of course. Because here you are not specifying which column of the CSV represent the label. So I think there is this convention.
Okay.
And it works like this. Okay, basically now in SageMaker you can choose lots of already built-in machine learning algorithms, like in, I don't know, like what happens in scikit-learn.
Yes.
And of course, there is a container that I think is something like a Docker for each of them. And here, basically, I'm loading the container this for the XGBoost model. Then here, I'm creating an estimator that is very, very similar to, even in the name convention, to scikit-learn.
Yes.
So basically, estimator is a model. I specify the container, the role, and then some more important, more interesting parameters. Here you can specify the number of training instances.
Yeah.
And the type of training instances. Of course, the more training instances and according to the type, the cost that you will pay changes.
Question. I have a question. How is the training distributed over the?
This is automatically handled by AWS. And then I will show you a sort of dashboard that tells you how the different jobs are going on while training.
Cool. That's really cool.
Just a thing that I noticed, that if you here set an high number of instances, but this is just an intuition, I'm not sure about this, you are blocked request to AWS to give to you the possibility to use more instances at the same time. But this maybe I'm not very correct. But there is something like this, because I got blocked at a certain point when increasing the number of jobs. This is another important parameter, the output path, and basically it represents the path into your S3 bucket, where the model, or better, all the different models will be stored. Because you will have a version of the model for each set of hyperparameters that you set. And this just a SageMaker session. So
another question. So let's suppose that I want to test the multiple classifiers, and XGBoost is one, and I want to test like 3 or 4 different classifiers. Is there a programmatic way to do it, or you have to just replicate this code?
I think that you should replicate the code, and just because the image, the container will change, because in this container you have all the libraries and all the dependencies for XGBoost. And so I think that it will change.
Okay, we're almost halfway through, Vale. We still have 15 minutes.
Okay, then you can set the basic hyperparameters here for your model. We will evaluate the performance in the area under the curve. This is the objective, that is in this case binary, because our classification task is a binary one. And this is a specific, maybe we can comment this, it's an error. Sorry. Okay. Here instead, this is not to comment. Here instead are all hyperparameters of this specific model that I wanted to tune, and this have been not chosen randomly. There is a documentation on AWS which is saying that these are the most important hyperparameters for the XGBoost. These are the most discriminative parameters for XGBoost in terms of optimizing its performances. And in this doc there is also some let's say best practice values for this parameter. And then you have to create this object, this hyperparameter tuner. That's basically, it's very similar to grid search CV in scikit-learn with the fundamental difference. Basically here you just have to provide the metric, of the model, of course, the metric for the evaluation, the set of hyperparameters that you just described here, and then max job and max parallel jobs. In particular, this is important, these max parallel jobs. If you set it to 1, you will have the best models in terms of the metric that you choose, because you can because the hyperparameter tuner will explore the space of the hyperparameters, finding, let's say, the best path.
Do you understand, Davide?
No, you're saying that it's better to set the max jobs to 1.
Yeah, because the hyperparameters tuner has to, of course, explore a specific path of hyperparameters in this space, right?
I'm not sure what you mean with path, but okay.
How can?
I mean, it's a grid search. It's not a tree, right?
Not exactly a grid search. The specific values for each trial of this parameter depends on the results, on the previous results.
Okay.
This is not a grid search CV. I mean, the hyperparameter tuner will not try with all possible all possible combination of hyperparameters that I wrote.
Are you saying that it will refine the search?
Yeah, exactly. Okay. And so if you set here to 1, you should get the best model, but of course the training would be slower, and vice versa, of course. So it's a trade-off. The important difference between grid search CV, apart this one, is that grid search CV is doing a k-fold cross-validation, and here no. This is just a cross-validation. Yeah, and then you just have to.
Have you already defined the ratio between the training and the validation set? Or?
The training, the original train CSV and the original validation, I call it test here, are already splitted.
Okay. Yeah.
And then you just have to call fit, and AWS will run the training under the hood. What you can see while the training is going on is you can go here, training, hyperparameter tuning jobs. This is one that I completed last time. Okay, first of all, here you can see the hours, and you will pay only for this time.
And that's an estimate. That's already completed, so that's what we.
Okay. Yeah. We paid 7 hours and so on for this specific machine.
Okay.
That is, and this is much and this is much expensive than the machine on which the notebook is running. And what you can see here is for each, basically all those rows are all the different models that have been trained. And yeah, you can see the training time, the target metric that you defined on the test set. Okay, this is not so good, this value, but just to explain to you. And then another interesting thing is that in some way, okay, there is best training job. That is the one with the highest target metric. And you can have let's say the corresponding best set of parameters here. Yeah, and just to show you what happens on S3, if maybe I have, okay, S3. S3. Second. Okay, S3. Okay, this maybe I should not. Okay, this is where I put my data, this test and train.
Yeah.
And this is the output directory. As you can see, there are different subdirectories, and each of them contains one trained model.
Okay.
And then you can take this, and for example, I used on my instance, and I don't know, like when you train a model on scikit-learn and you then say it as Pickle, just like that. Yeah.
Excellent.
And
now,
yeah, so just last thing, I didn't. There is the possibility to very easily here deploy the model into an API that you can reach by HTTP. I didn't do it because I didn't
directly.
need.
You can do it directly.
Yeah, you can do it here with some commands, like similar to what I did here.
So you can deploy directly into an API.
Yeah, absolutely.
Wow.
And also with some easy commands, you can uninstall that API.
That's powerful.
Yeah, and this is another advantage. I didn't try it, and yeah, that's it. So at least two main advantages for AWS.
Hang on. You're going too fast. Davide, do you have questions or comments before we conclude by listing the pros and cons of SageMaker versus a standard approach, which involves an instance with a local installation of Jupyter and usual libraries? Any questions, any comments, anything?
No, I guess that you previously defined the instance to run the jobs, right?
Yeah.
The instances must be selected depending on the size of your data set.
Yeah. Because in this case, we know that XGBoost works loading all data into the memory. In fact, here before I was using instead of 2xlarge, I was using xlarge, and I ran out of memory.
Okay.
All right.
So I increased.
Okay. All right. So I'm going to share my screen. I'm going to share my notebook. And my notebook is here. There you go. All right. So we have two solutions. We have the local, let's call it local instance. And then we have SageMaker. Let's examine the pros and the cons of both approaches. Okay, so let's start from SageMaker, since you have been using it so far. So what are
the pros are surely it allows you to save money.
Great.
Not only for the processing time, but also for storing data.
Okay.
Then when you have mini experiments that can be parallelized, I think that this is the best solution, because the parallelization is, let's say, handled by a SageMaker.
Okay. Anything
and then
else?
there are some other interesting characteristics, like you can integrate SageMaker with annotation job and so on. You can integrate SageMaker notebooks into the typical pipeline of machine learning. So from labeling data to deploying the models and so on.
Yeah.
And reusing the model for annotating new data and so on.
Yeah. Okay, cons.
Cons, this pipeline might be complex for very, very specific problems. And
for instance, video analysis. How do you handle video analysis or video recognition with SageMaker?
Yeah, then you have only 5 gigabytes as storage. You can increase it, but at that point you can just use a classical instance.
Okay, so let's have a look at local instances now. What are the pros?
And one more important cons of SageMaker, sorry,
Yes.
Luca, is that if you want to train with your custom algorithm, maybe written in PyTorch or TensorFlow, whatever, you can do it using more or less the same code that I just wrote, but your training script should be a .py file, so it's difficult to debug.
Okay, so difficult to debug. Interesting. If you go bespoke, it's difficult to debug. Okay.
Yeah. From different point of views.
Okay. So what is the advantage of local instance or local installation?
Well, you have data locally, so it's easier to access them, explore them.
Yeah.
Even before training.
Yeah.
Then easy to maybe install libraries, some libraries, because you have the operating system, you can do whatever you want.
Yeah. Excellent. And well, the cons, I mean, they are implicitly defined. It's more expensive. It's probably
more expensive, and if you have experiments that can be parallelized, you have to parallelize them on your own.
Excellent. And we are on time. Okay. How good is that? Valerio, thanks a lot. This was brilliant. Very interesting.
You're welcome.
Very interesting. And we are going to publish this video on our website so that whoever is interested in learning how to use SageMaker to train an XGBoost, well, they can rewatch it, discover it, and reproduce it. So thanks for watching, and have a great weekend, guys.
Bye-bye.
Bye, guys.